Hello and welcome to Vision 2016 here in Stuttgart, Germany. My name's Colin Pearce. I'm the CEO of Active Silicon. I'm going to spend a few minutes talking about the company, the products and some of the demonstrations we have here today. So, what do we do as a company? We're in the imaging and embedded systems business, and we sell to customers that are designing larger systems, typically in the field of medical imaging, medical devices, life science, industrial automation and various other niche product areas. So, focusing in a little bit more detail on the products now, we have three product ranges. The first range is interface cards or frame grabbers, and I have a selection here. We have some small, low-cost ones, and we have some rather larger, powerful ones, generally aimed at high-speed acquisition from high-speed cameras. The second product area is again interface boards, but this time at the camera end. So these are much smaller boards. What these will do will take sensor data, convert it to a certain format for transmission off to an image processing system. So we have an example of one there, and we have another example here on a block camera, and this was our product on the back here. And then the third and final product area is embedded systems. Now, an embedded system is where we're actually integrating some of the acquisition technology in with an embedded PC and some other I/O control, which is used for perhaps machine control in a certain machine application. As an example here, so we've got a powerful processor, we've got some, this is a 4-channel USB 3, and this is used inside a machine, in fact a medical device machine, and it's a good example of what we can do with custom embedded electronics. Now, the key benefit with this semi-custom approach is that the fit, form and function of this unit will remain the same for many years. That's very, very important in certain applications in regulated industries, such as the medical industry, where they'll integrate a product and they don't want to change it for many years. They want it to be the same. It's a challenge in technology, a rapid changing market where processes are changing regularly. What we can do, we can basically provide the same thing for many years. So that's a quick summary of us, the products, the company. What we're going to do now is have a walk around the booth here, and I'm going to show you some of the product demonstrations we have here today. This is the first demo I'd like to show you. This is using our flagship Co-Express Firebird frame grabber, and the demonstration here is acquisition at high speed from 4 independent cameras. So each of these cables here is carrying data at 6.25 gigabits per second. So relatively straightforward demo. Really what we're showing here is a single board, high-speed acquisition from 4 cameras, all running asynchronously. So that's the first one, and now what we'll do, we'll move on to the next one. Okay, this is the second product demonstration I'd like to show you today. The setup we have here, we have 4 USB 3 vision cameras going through 6 meters of USB 3 cable. It's an active cable to get the distance and the speed, going into our product, which is an embedded vision system. So we have 4 USB 3 vision inputs and 4 3G SDI outputs. The application here is in a medical device. The guts of what's inside this unit is actually this unit here. This is a custom embedded PC that we've made for a specific customer to sell in volume into that market. And now we're going to move on to the third product demonstration over here. This is the third product demonstration I'd like to show you today. So what we have here, we have a high-speed camera, quad Co-Express cables going into our frame grabber that's underneath in a PC, and what we're showing here is CUDA processing using the GPU. The GPU is the graphics processor unit, and that's a commodity item now in the PC world. And it's extremely powerful at doing image processing. The example we've got going on here is acquisition from a Bayer encoded camera, and the Bayer pixel encoding is then being converted into full RGB color, all by the GPU processor. So we're not actually using any CPU processing at all. So this demo is running at 2 gigapixels per second. That's a huge amount of data, very fast, and all using no CPU. This is the fourth and final product demonstration I'd like to show you today. This is using our Firebird acquisition card, but this time it's in compact PCI form factor, which is an embedded form factor. So the demonstration we have here, we're using this card inside this system, and we're actually doing a very simple old school animation, but with modern technology. So what we have on this printed disc here, we have a sequence of images. As you can see here, we have an encoder that's triggering the camera in synchronicity with the spinning disc. So that way, using this camera we can capture these images and recreate the running man. It's a nice little example of showing triggered acquisition in an embedded vision system. So that was the fourth and final demo. Thank you for watching. I hope you found it interesting. Please do come and visit our website at activesilicon.com and see how we can help you in the development of your products. Thank you.